I'm going to work through here with you on how to create a line of best fit and apply that line using desmos, okay? So just briefly, as you recall, what we've been doing is using y equals mx plus b, which is what we call slope-intercept form of an equation. So we're really going to be doing the same thing, it's just that we're using a data set. And from there, you're going to expect to get lines that have different types of slopes and y-intercepts that are decimals and aren't exactly all on the line. So when we plot these points, we want to get what's called that line of best fit. So it means we understand it's not perfect, but we're going to get the best representation that we can. Okay, and we're going to use desmos to help us in terms of the technology. So anytime we do these questions, we're going to have a data set. So we see that here. So the first thing I think is good to do is just to label what is your x value, which is in the table, is always the side on the left, and what your y value is, which is always the side on the right. And then from there, I would take a look at what is the topic, what's the title, and what does the data tell us before we've even done anything else. So here I see the x is hours spent studying, and as I read, I see it goes 1, 3, 6, 8. So it's it's going up the whole time and slowly. And then on the right-hand side, I see it says for the y value, score on the final exam. And again, 50, 60, 70, 85. I see it's going up again slowly. So before I've even done anything, I know that well, x is going up and y is also going up. So when x goes up, y also goes up. That's telling me before I've even gone to the graph that I should be looking for a positive slope. So that line should be looking like it's going up as we read it from left to right. Well, now I want to get the exact line. So rather than like trying to do and find the slope from the points and use that, we're going to use desmos so we can get an exact specific line. So how do we do that? Well, first go to desmos.com and then click for the calculator button so that you get to this screen. Then from there, you want to hit the plus sign right here where it's going to say add item. And we're going to click on the table. And you'll notice it'll bring this up where it says x sub 1 and y sub 1, which is how you say that. And with the x sub 1 and the y sub 1, it's just saying, hey, what's your data that you're working with? So x1 or x sub 1 is going to be my x values here, 1, 3, 6, and 8. So I'm just going to type those in here, 1, 3, 6, 8. And now I'm going to type the corresponding y values. So I look for my y values, 50, 60, 70, and 85. So I'm going to type those in here, 50, 60, 70, and 85. So now that I have all of those values, you'll notice you don't see any of the points written or put down on our coordinate plane. And that's because these y values are so big. Now, you can just try and zoom out a whole bunch of times until you eventually find some points. But the best thing about Desmos with this is it's going to show you right here, if you look at this magnifying glass, it says zoom fit. So go ahead and click on that and you'll notice it sets it up so you can see the points nicely and it gets your window just right so you don't see a whole bunch of other stuff as well. So now we want to create our line of best fit that's going to go as best we can through these points. So on the line 2, you want to type in our y equals mx plus b, but we need to make a few changes to represent this table. So our y isn't just y, it's y sub 1. So we're going to type in a y and then hit your number 1. And then we need, this is an approximation, it's not specific. So to get your approximation symbol, you're going to hit shift and then the button right underneath the escape sign on your computer. It'll produce that little squiggly line, okay? And now we're going to hit M for the slope, and then we need to represent the x variable, which in this case is x sub 1, so we're going to hit x, and then the number 1 again, so you'll see that, and then always that y-intercept on the end, so we put a plus b. Okay, so now we see our line, and it just showed up, and it goes basically through the points. Again, it's going to be a straight line, so it's not going to go exactly through all the points, but it should generally represent the data points, which it does. So now we have the m, which is our slope, we have the b, which is our y-intercept. So I'm going to round this to 2 decimal places, but you could round it to 1 or 2 depending upon what you'd like or what the directions say. So in this case, the m, or the slope, is 4.74, so I'm going to put that down, and I'm going to write that for my line of best fit. So y equals 4.74x, and then I'm going to go and put in what my b value would be. So that's 44.91, so I'm going to type that in as well. So 44.91. Now, That's just to find my equation. So that's the equation that represents the line of best fit for this problem. Now, let's look at the questions that ask us to apply the line. So now, here it reads, if a student spent 7 hours studying, what grade should we expect them to make on the exam? So in all of these scenarios, what's going to happen is it's either going to give you the x value and you have to find y, or it gives you the y and you have to find x. And that's what we really need to determine. So here it says if a student spend 7 hours studying, so okay, 7 hours studying, was that my x or my y? Well, that's the x. It says here, hours spent studying was x. So basically, this is saying when x is 7, what's y? Okay, now here's our key that's going to be different. We're not going to use this equation because remember we rounded that equation. We want a specific answer. So what we're going to do is use this x equals 7 in desmos. So click on line 3, you're going to type x equals 7. And now you want to go to that intersection point. So you see here we see 78.1. So that's my y value there. So we're going to say, I know what y would be. Y would be 78.1. Now, when we do that, let's try and make sure we understand this in terms of a sentence. So if I was to make a sentence about this, I would say, if a student spent 7 hours studying, we would expect them to make a 78.1 on the test or exam. Okay, so now let's read question 16 to finish. If a student made a 75 on the test, how many hours would we expect them to have studied? Well, now the 75 is the test score, so now it's giving us the y. So this is saying, hey, if y is 75, what's x? So it's the same thing, but in reverse, okay? So now we're still going to do that through desmos, but now I'm going to type y equals 75. Personally, I like to get rid of the other line so I don't have to see it. I think it can lead to some confusion. If it doesn't bother you, you can keep it. But I'm going to type y equals 75. Again, I go to where the lines intersect, which is right here. So now I see my x value, 6.345. So I'm going to round it to 2 decimals. So the 5 moves the 4 up, so 6.35. So that's an x value there of 6.35. And that would be my answer for this problem, which in terms of making it into a sentence would be, if a student had made a 75 on the test, we would have expected them to have spent 6.35 hours studying. Okay, I hope this helps you go through how to use the desmos to find the line of best fit from a data set, and then also how to apply it both when you're missing x and need y, or when you're missing y and need x.